Hello guys, you're welcome to Vince Tech class. And in today's tutorial, I'm going to walk you through hyperparameter optimization of XGBoost. We start by importing our necessary libraries. These are our necessary libraries. Next, we load our datasets. And the dataset used for this project is the Cleveland Heart Disease dataset. Next, we use the head function to view the first 5 rows of our dataset. And if you can observe from the output, this is the first 5 rows of our dataset. Next, we see the shape of our dataset. And from the output, we have about 14 features and 303 instances or observations. Next, we use the nUnique function to view the categorical variables and the continuous variables. Like an example, age is a continuous variable, sex is a categorical variable, BP, that is chest pain, is a categorical variable, and trace BPX, the continuous variable, and so on. Next, we see the data type information of our data set. And if you can observe from the output, only the old peak has a float data type. Next, we use the isNull function to see if our data set contains any null value. And from the output, it can be observed that our dataset does not contain any null value. Next, we check for duplicates. And if you can observe from the output, it says duplicate row in dataset are 1. That is, we have only one duplicate row, and we use the key force to drop the duplicate row. Next, we use the describe function to view the statistical information of our datasets. For example, we have the age. Its count is about 303. Its mean value is about 54.37. Its standard deviation is about 9.082. It has a minimum value of 29. That's the minimum age. It's about 29. Now, 25th percentile is less than 47.5. 50th percentile is less than 55. And 75th percentile is less than 61. And we have the maximum age in our dataset to be 77. Likewise, other features. This is just the statistical information of our datasets. Next, we use the box plot to view outliers. Outliers are just observations which are different from normal observations, and this could be to variability in measurement or error in measurement. Now let's observe our trace BPS. We can observe few outliers. Also in cholesterol, we can also observe few outliers, and fasting blood sugar. We can also observe about 1 outlier. Next, we use the interquartile range method to detect and remove outliers from the continuous variables. This is just the formula. You can make more research on this interquartile range method to get more insights about this method. This is just the formula. Next, we remove the outliers using the drop function. These are the number of outliers. We use the drop function to remove the outliers. And if you can observe from the output, it says outliers from age feature removed. Likewise, other features. Next, we convert the categorical variable into objects because Python detects categorical variable as objects. We convert our categorical variable into object data type. We also help the model to perform better. Next, we use the isNull function to check if our dataset contain any alphabetical entry. And if you can observe from the output, they are all false, showing that our dataset does not contain any alphabets as instances. Next, we plot a bar plot to see how our target variable is being distributed. And if you can observe from the output, about 55.99% of patients has heart disease, while 44.01 is without heart disease. It's just a part of data visualization. Next is the histogram of the continuous variable. And if you can observe from the output, tracing BP is slightly left skewed. We can also observe for TALAC, which is also right skewed. And OPIC is also left skewed. Let's view another data visualization. From this visualization, we can infer that men suffer more from heart disease compared to women. Next, we convert our categorical variable into one-hot encoding. So it's always a good practice in machine learning to convert your categorical variable into one-hot encoding to help the model perform better. And we scale the continuous variable using the min-max scalar function. Next, we separate the target variable into the x and y. Then we drop our target variable from the main data set. Next, we split our data set into training and testing. The test size is 0.2. That is 20% of our data will be used for testing, while 80% will be used for training. And we have our random state to be 42. Next, we set our random seed to be 42. Now, the essence of setting this random seed to be 42 is to prevent our model accuracy from changing each time we run the model. Now comes the main problem of this project using XGBoost. First, we define our XGBoost classifier. This code here will print the accuracy and the AUC score before applying hyperparameter optimization. Now we'll view our accuracy and the performance metrics before and after applying hyperparameter tuning. Next, we define the grid of hyperparameters to search. We have the n estimators, we have the maximum depth, we have the learning rate, we have the subsample, and also we have the volume sample by tree. This is just the param grid of XGBoost. Next, we create a search CV object with cross-validation of 5. Next, we feed the grid search to our training data, and we get the best hyperparameters. Next, we get the best estimator with the tuned hyperparameter, and we'll make prediction on our test data sets. Now, let's see our output. These are the output before applying hyperparameter tuning. We have accuracy of about 82%, and we have area under curve to be also 82%. Now, let's see the score after applying hyperparameter tuning. These are the best hyperparameters. Now, after applying hyperparameter tuning, we have our AUC score to be 90%, showing that there is an increase of about 0.8%. And we also observe our accuracy, which is about 89%. Previously, it was 82. Now is about 89, showing there is an increase due to the hyperparameter tuning. Next, finally, we view our confusion metrics. And don't be confused, you can make more research on this to gain more insight on this project. This is the true positive, and this is the true negative. And 4 and 2 are the type 1 and type 2 errors. You can make more research on this, you get more insight on these projects. So guys, that's all for today's tutorial. If you have any question, leave them in the comment section below, and please don't forget to like and subscribe to my YouTube channel. Thank you.